Cloud formation is a dynamic atmospheric process governed by thermodynamics, fluid mechanics, and phase transitions. It begins at the Earth's surface, where solar radiation heats the ground, subsequently warming the air in contact with it. This warm, moist air becomes less dense and rises through the atmosphere in a process known as convection. As the air ascends, it encounters regions of progressively lower atmospheric pressure. This causes the air to expand adiabatically, meaning without heat exchange with the environment, and, as a result, it cools. The cooling rate depends on whether the air is saturated or not, typically around 10 degrees Celsius per kilometer for dry air, known as the dry adiabatic lapse rate. When the rising air cools to its dew point temperature, it becomes saturated with water vapor. At this stage, the air cannot hold any more moisture in vapor form, and condensation begins. Water vapor condenses onto tiny airborne particles such as dust, salt, or other aerosols known as condensation nuclei. These particles are crucial for droplet formation, as they provide surfaces upon which water molecules can aggregate. The condensation of water vapor releases latent heat into the surrounding air, which slightly warms it. This warming can enhance the buoyancy of the air parcel, further driving it upward and promoting additional condensation, a feedback mechanism that supports cloud development. The thermodynamic basis for this process is described by the Clausius-Clapeyron equation, which relates the saturation vapor pressure of water to temperature. As temperature decreases, the capacity of air to hold water vapor declines exponentially, thereby encouraging condensation at lower temperatures. The aggregated water droplets formed are very small, typically with diameters of around 10 micrometers. These droplets scatter sunlight effectively, making clouds visible from the ground as bright, white formations. In colder conditions, especially at higher altitudes, ice crystals may form instead of liquid droplets. Overall, cloud formation is a product of the intricate interplay between temperature, pressure, humidity, and the physical properties of water. It exemplifies key concepts in atmospheric science and thermodynamics, highlighting how changes in state and energy transfer shape the weather and climate systems we experience daily. Please like, share, and subscribe.